There is one new equation in this section. It is called the range equation. Let me write that out for you now. It's called the range equation. The range is equal to the initial velocity squared times the sine of 2 times the initial launch angle divided by little g, the acceleration due to gravity. And yes, I'm going to walk my way through this equation several times. We'll talk about everything that's in here. The range is equal to the initial velocity squared times the sine of 2 times the initial launch angle divided by g. Range has a specific definition. The range is the displacement in the x direction when the displacement in the y direction is equal to 0. Via a picture that looks like this. The object has some sort of initial velocity, initial launch angle. It goes up. It comes back down. This range is the delta x, the displacement in the x direction, when the displacement in the y direction is equal to 0. You can see that visually in the picture. We'll take the moose. The moose has an initial launch. It goes up, comes back down. Class, did the moose go up and down? It had motion in the y direction. But what's the overall displacement of the moose, class, in the y direction? 0, right? So the overall displacement of the moose in the y direction is 0. Therefore, the range, the displacement in the x direction, is called, or the displacement in the x direction is called the range. Now, this initial velocity, one of the things that I've said is whenever you're given a vector that's neither directly in the x direction or the y direction, the first thing you should do is break it into its components. I did say that there would be some times when that is not true. This is a special case where you are not going to break that initial velocity into its components. You are going to use the magnitude of the initial velocity because this theta, which is included in the equation, is the launch angle. So it's already in the equation, this theta. So you do not need to break the initial velocity into its components. You already have that. Megan, what is the value of g, the acceleration due to gravity, little g, here on planet Earth?
Negative 9.8 meters per second.
Negative 9.8 meters per second squared, which is why I go through this specifically, because, Shira, it's positive. But for some reason, because the first time I introduce it, the acceleration in the y direction is equal to negative g, therefore the acceleration in the y direction equals negative 9.8 meters per second squared. For some reason, students have this idea that g is a positive number. Or sorry, that g is a negative number. G is a positive number.